AI companies are spending hundreds of billions of dollars to build the future. But there's one uncomfortable problem. The future they're selling still has to be built in the real world. Every time you ask an AI chatbot a question, generate an image, write code with an AI assistant, or run a company workflow through a model, that request has to travel somewhere. It goes to servers packed with expensive chips, inside data centers that need land, cooling systems, power lines, substations, transformers, backup generators, and a huge amount of electricity just to stay alive. So AI may feel weightless on your screen, but behind it is one of the most physical, power-hungry build-outs the tech industry has ever attempted. And that's where the story gets uncomfortable. A huge chunk of the data centers needed to run this AI future may not arrive on time, and some may not arrive at all. Because you can raise money fast, you can announce new models fast, you can hype the future fast. But you cannot build power grids, transmission lines, substations, and massive data centers overnight. So the real question is no longer just whether AI is powerful. The real question is, can the physical world actually keep up? And if half of these AI data center projects are quietly getting canceled or delayed, that may be the first warning sign that the AI boom is running into something very real. The hard limits of land, water, chips, wires, and electricity. Want to know if tech is being overhyped? Just follow the money. In 2025 alone, the biggest companies out there are dropping something like $400 billion on AI infrastructure. That's not pocket change for some fancy demos. We're talking data centers, GPUs, power systems, cooling, networking. The whole damn foundation AI needs to actually work at scale. Put that in perspective, adjusted for inflation, that's like 9 Manhattan projects or 2 Apollo programs, all crammed into one single year. And that's just the infrastructure side. Hell, they're even spending more on AI data centers than on building new single-family homes in the same period. And remember, this number doesn't even count the private spend from OpenAI or Anthropic, or all the extra costs like people, electricity, and security. So yeah, the money pouring in is insane. But here's the contradiction that's starting to bother me after nearly 4 years since ChatGPT blew up. Most of these companies still haven't clearly shown that AI can actually make real, sustainable profits that match all this cash they're burning. The big exception? Nvidia and the guy selling the shovels. You know the old gold rush line? The ones who really got rich weren't always the miners. Sometimes it was the guys selling picks and shovels. Right now, Nvidia is selling the shovels and they're making a killing. But that raises a pretty uncomfortable question. If Nvidia is shipping all these chips, where the hell are they actually going? And who's really using them at scale? Alright, let's talk about where all these Nvidia chips are really going. Nvidia sits right in the middle of the whole AI wave. Train a big model? GPUs. Serve millions of users? GPUs. Scale the cloud? Still GPUs. Jensen Huang says they're shipping enough chips in 2025 to support roughly 10 gigawatts of power. That's a massive amount of compute and electricity. But here's the weird part. Industry estimates put the total AI data center capacity actually running worldwide right now at only about 7.7 gigawatts. So if those numbers are even close, where's all that extra chip capacity disappearing to? Sure, new projects get announced constantly, but when you look closer, a lot of them are still just foundations, waiting for power, delayed, downsized, or quietly vanishing. One study looked at 21.5 gigawatts of announced capacity supposed to come online before 2027. Only 6.3 gigawatts were actually under construction. And even under construction can mean anything from almost finished to we just poured concrete. Don't forget, when companies talk gigawatts, that's total electricity for the whole facility. According to the IEA, only 46% to 65% actually goes to the GPUs. The rest is cooling, networking, and overhead. So if a big chunk of this future capacity still only exists on slides, the market may be betting on much faster growth than the real world can deliver right now. It doesn't mean AI is fake, it just means the physical build-out is happening a lot slower than Wall Street expects. So here's the confusing part. Tech companies are spending hundreds of billions of dollars buying mountains of Nvidia chips and announcing new AI data centers almost every week. So why does the computer still feel scarce? Because what matters is not how much capacity gets announced. What matters is how much capacity is actually running. AI is no longer just people asking chatbots random questions. Companies are using it to write code, analyze documents, handle customer support, automate sales, build agents, and run workflows that used to take entire teams. Every one of those tasks burns through tokens, and behind those tokens are real chips, real servers, real electricity, cooling, and data center space. So demand is already here, but the infrastructure needed to serve that demand is arriving much more slowly. A chip sitting in a warehouse does not help anyone. A data center waiting for power does not answer a single prompt. Until the servers are installed, powered, cooled, and connected, that computer does not really exist for users. That is why the shortage still shows up everywhere. GPU rental prices stay high, users hit tighter limits, AI companies have to decide which features get priority. Some tools slow down when demand spikes. Some services become unreliable because there simply is not enough ready-to-use capacity. Anthropic is a good example. It has grown incredibly fast, but that growth has also come with repeated outages and capacity issues. And when enterprise customers build real business workflows on top of your models, downtime is not just annoying, it can push them to look for another provider. So the bottleneck is bigger than chips. The industry can raise money fast, announce projects fast, and order hardware fast. But turning all of that into usable compute takes buildings, power connections, cooling systems, transformers, substations, and time. That is why AI companies can spend like crazy and still feel short on computers. Demand is real, the money is real, the chip orders are real, but the working capacity is not arriving fast enough. And the biggest reason may be the one part of the AI boom most people barely think about: power. You can buy all the chips you want, but if you don't have the electricity to turn them on, you're basically just sitting in a warehouse full of really expensive paperweights. Everybody loves to talk about GPUs. And yeah, they matter a ton, but GPUs are only one piece of the puzzle. A real AI data center needs way more than chips. It needs massive electrical capacity, substations, transmission lines, cooling systems, backup power, the whole infrastructure to actually handle the load. Andrew Pearson at the Wall Street Journal made a really good point. He says when you build a data center, you should also count the cost of building the dedicated power generation that goes with it. Why? Because the grid is already stressed. If a new data center just sucks more power out of the shared system, we're hiding part of the real cost of AI. In some places, one single data center needs so much juice that it basically has to be treated like its own power plant. And it's not just the grid. Local communities are pushing back hard against having these things built in their backyard. So here's the bottom line. AI often looks more profitable than it really is because the market isn't fully pricing in the huge cost of electricity and power infrastructure. And that matters a lot. Because if every new data center comes with its own massive energy bill attached, then the expected returns on this whole AI boom need to be questioned again. Power is the biggest bottleneck, but water is becoming the next fight. Data centers create a lot of heat, and many of them need water for cooling. That doesn't mean AI is about to drink all the water. Compared with agriculture or other heavy industries, data centers may not be the biggest water user, but the pressure is local. If a town is already dealing with drought, old infrastructure, rising utility demand, or concerns about drinking water, a massive AI data center can quickly become controversial. People may accept water going to homes, farms, and hospitals, but giant server farms built for AI companies are a much harder sell. So water may not be the main limit on AI, but it adds to the same problem. This boom needs real land, real utilities, real cooling, and real community approval. And every extra constraint makes the build-out slower, more expensive, and harder to scale. Nvidia has been the biggest winner of the AI boom, but if the whole build-out starts getting out of sync, Nvidia may also be the first place where Wall Street notices the problem. Because Nvidia is no longer just another chip company, it has become the symbol of the AI trade. When investors believe AI demand is unstoppable, Nvidia benefits. When they start questioning whether the infrastructure can actually keep up, Nvidia is the name they look at first. So there are three big questions hanging over the company right now. First, where are all those chips actually going? Are customers running them at full capacity, or are some of them being bought ahead of data centers that are not ready yet? Second, do more chips actually solve the real bottleneck? If the buildings are unfinished, the power is not connected, or the cooling systems are not ready, then selling more GPUs does not create usable AI capacity by itself. And third, can Nvidia's customers turn all this spending into real profits? Because if the companies buying these chips cannot prove that AI generates enough money to justify the cost, eventually the market will start questioning the whole growth story. That does not mean Nvidia is weak. It means Nvidia sits at the most sensitive point in the AI economy. If data centers get finished, power comes online, and customers start making serious money from AI, Nvidia can keep winning. But if demand, construction timelines, power availability, costs, and profits start drifting apart, Nvidia will be the first name under the microscope. The real question is not whether AI looks impressive. It is whether AI can become a sustainable business at this scale, and whether Nvidia is showing us real demand or expectations running ahead of the physical world underneath it. So, is this whole thing an AI bubble? This is where people usually split into two camps. One side thinks AI is obviously the future and cannot possibly fail. The other side thinks the whole thing is just one giant bubble. The truth is probably somewhere in the middle. AI clearly has real value. If it didn't, we would not see this much demand for computers, companies would not be paying sky-high prices for GPUs, and the infrastructure would not be under this much strain. But real value does not mean every dollar being thrown at AI right now is smart. That distinction matters. A bubble does not mean the technology is fake. It means money, expectations, and valuations are running faster than the real world can build the infrastructure and generate the profits to support them. So AI probably is not going away, but the market could still face a painful correction. Projects may get canceled, spending may get cut, and valuations may finally have to answer the uncomfortable question: is AI generating enough real money to justify the insane amount of investment we are seeing today? And this is where the story stops being abstract. Because if AI is running into real bottlenecks, compute, power, data centers, cooling, all of it, those costs do not stay hidden inside server farms forever. Eventually, they show up in the products people actually use. You may not see a data center delay directly. What you'll see is a $20 plan becoming $30. A generous usage limit suddenly gets tighter. A feature that used to be included moving behind a pro tier, or an AI tool that feels amazing at 10 a.m. and painfully slow when everyone logs on after lunch. That is how this bottleneck reaches the user. Not as a headline about transformers and substations, but as higher prices, stricter limits, slower performance, and features quietly disappearing because they cost too much compute to run. So yes, this may look like a story about data centers, power grids, and Nvidia. But sooner or later, it becomes a story about what you pay, what you get, and what starts disappearing from the AI tools you use every day. So in the end, here's the real question. Are our expectations for AI running way ahead of the actual infrastructure underneath it? And if that physical bottleneck keeps getting worse, don't be surprised if you feel it first through higher prices, slower AI tools, tighter usage limits, and features that quietly disappear. That's the big question the market has to answer over the next few years. AI may keep getting more powerful, but can the real world build fast enough to support it? If you like this kind of straight talk breakdown, do me a favor, hit that like button, subscribe, and drop your thoughts in the comments. So what do you think? Are AI tools about to get better for you, or are they about to get more expensive, more limited, and a lot less magical? Let me know what you think. See you in the next one.